All right. So we've, done exponential functions for a couple of days now. We know how to graph them, what the graphs look like. Today we're going to do some applications. The first of those is the compound interest formula, which you will have seen in your last year's classes. So basically, compound interest is when you have money in the bank account, which gains interest. But let's say you put like $10,000 in the bank. The first, year or whatever, it gains some interest. So suppose now you have $10,100. The next time you earn interest on the total, so not just the 10,000, but the 10,100. So this is called compound interest. Okay, so to calculate compound interest, there is a formula which you have to memorize. And the formula is this: A equals P 1 plus R over N to the NT. Okay, so what are all these things? In this chart at the bottom, I've identified each of the variables. So the first one is A, right, which I've written down here. A is the final balance in the account. So when you get your statement, how much money is in there now? That's A. P is the principal, right? But not like principal like Ms. Howard, but it's the principal, which means like this is the money that you first invested to open the account. This R is the rate, but remember it has to be in decimal form. So remember to divide the number that you're given in the problem by 100. T is time, usually in years. N, it shows up twice, okay, here. N is the number of times within the year that the customer is paid by the bank. And this depends on what type of account you have. So for example, if the account is something that pays you annually, can you please put your calculator away right now? We're doing this right now. So if the bank pays you annually, how many times a year is that? One. So in that case, N is equal to 1. If it's semi-annually, how much is N? 2. Quarterly, 4 times a year. Monthly, 12. Daily, correct. Okay? All right. So let's take a look at this one. Mrs. Algebra invests $2,000 into an educational account for her son when he was an infant. The account has a 5% interest rate. So they invested $2,000. That's the principal, right? So we're going to write that here. We're going to make a little cheat sheet for us. 2,000. It has a 5% interest rate. So R is, divide that by 100, so 0.05. If Mrs. Algebra does not make any other deposits or withdrawals, what will be the account balance after 18 years? So T is 18. And we want the account balance, which means that's A. Okay, A is what we need. Okay, and here, if it's compounded as follows, so in part A, it's compounded quarterly, so N is equal to 4. All right, so let's go ahead and plug that in here. So A is P, 1 plus R, over N is 4, to the power of 4 times 18. So let's go ahead and plug that into the calculator. Go ahead and take out your calculators at this point. We're going to plug the whole thing into the calculator in one shot. So it's going to be 2,000 times 1 plus 0.05 over 4. To exit this, you can either press the right arrow or tab to the power of 4 times 18. You see how you can just put everything in there in one shot? And you should get $4,891.84. So rounding is super important here. This is money, so you have to round it to like dollars and cents, 2 decimal places. Round it correctly, please. Right? So if you have to round, if it's 0.84, it's 0.84. If it's 0.85, it's 0.85. We can't make a mistake. Imagine if your bank was off by a penny for every single one of their customers for like 20 years. It would be millions of dollars like towards the end, right? So no mistakes. Okay. Next one now says, what if it was monthly? So the only thing that changes here is n equals 12. So it's going to be A equals 2,000, 1 plus 0.05 over 12 this time to the power of 12 times 18. Now when you go in your calculator, please don't type the whole thing over again. Let me show you what to do. Press the up arrow button once, twice. Highlight this, press enter. Now you get the same thing in editable form. So just go in there and change the 4s to 12s. It's so much easier, right? Less keystrokes, less mistakes. So now we get $4,910.02. Okay, next, go ahead. I'll give you 2 minutes to do the one for daily. So modify and enter in your calculator. 2 minutes. So we got 4,918.90, right? So take a look at what's happening here. In the first situation, this person is getting paid 4 times a year, then 12 times a year, right? So it makes you think we're going to get so much more money. But look at the difference between 4,891 and 910. Like, that's not much money at all, right? Over 18 years especially. And then this one, they're getting paid daily for 18 years. And you're like, man, they're going to be millionaires. But look at how much more. It's like $8 more than, what they were getting monthly, right? So do you see how, it kind of starts to level off at some point? That's because of the way the formula is constructed, okay? Yeah. So do you see, okay, so we went from quarterly to monthly to daily, and we thought if we're getting paid daily, oh my gosh, we're like really going to be rich now. So what if we increase it a little bit more? What if instead of getting paid daily, you are getting paid every nanosecond of every minute of every day? So how many times are you getting paid in a year at that point?
Whatever, seconds are in a year.
Unlimited, an infinite amount of time, right? So n is now infinity, right? When that happens, this formula changes and our favorite base, e, comes in its place. So now the formula becomes a equals pe to the rt, and we call this continuous compound interest because you're literally getting paid continuously. So Mrs. Algebra found an account that will pay 5% interest compounded continuously. What will be the account balance after 18 years? Well, so now A is going to be 2,000 e to the power of 0.05 times 18. Now she's really going to be into this, right?
What happens to the 1 plus?
Okay, so when it's continuously, the formula changed to what I've highlighted. Okay, so go ahead and plug that in. And how much money are we going to make now? Remember, we only had 49.18 before.
Now
49.19, 21. So a whopping $1 more. Right? Because remember what we said? That number levels off to E 2.7. So that, formula will eventually level off. Okay, so moral of the story. When you have these formulas and you have compounded quarterly, monthly, whatever, you're going to use this formula with the n. Only when you've got the magic word continuously do you use this formula? Yes? Okay, now, these two formulas are for interest only. Okay, listen. These two formulas are for interest only. The problem has to be, you've got a bank account, money invested in the bank account, and you're getting interest. For all other problems, like bacteria in your body, population increase or decrease, radioactive material decaying, salary increase, decrease. Even though salary is money, it's not money in a bank account earning interest, right? House properties increasing or decreasing, car property, whatever, car value increasing. For all those other ones, we have these lovely formulas. Okay? So, whether it's populations of people, bacteria, animals, radioactive material, whatever, it's this. Okay. So, when you have exponential growth or decay, this is the formula you're going to use. Okay. If the specified quantity is increasing, we use positive R. If the quantity is decreasing, we use negative R. Okay? So these are things that are like, increasing once a year, but like an annual rate. Okay. If you've got the magic word, continuous, then the formula changes with the E. Again, now it's N equals N naught e to the KT. Oh, so what about this N and N naught business? What is that? So whatever the quantity is, that's the final N. This with the subscript 0, this is the initial amount. You don't. Yeah, don't mess with the calculators for the time being. I'll walk you guys through this. So if the quantity is increasing, positive K, decreasing, negative K. Cool? Okay. So let's do this one. So again, these are the, if you forget what each of the things stand for. Okay, so take a look at this one. A state's population is declining at a rate of 2.6% annually. The state currently has a population of approximately 11 million people. Oops. Okay. If the population continues to decline at this rate, predict the population in 15 or 30 years. So let's write down the given. First of all, let's decide, are we going to use the formula to the left or the right?
Left.
Left. Because that magic word isn't in there. So N equals N naught 1 minus R, or you know what? I'll do this. Okay, sorry. I'll just do it this way.
Is that a 0?
1 plus R to the T. Yeah. Okay, so let's see what we have. The rate is 2.6%. But because it's declining, it's negative 2.6%, which is negative 0.026. Okay, what are we given? We're given the initial number of people, N naught, is 11 million. How much is the time for this one? 15 years. So we want the final amount, which is N. So let's do this. N is, okay, you see the 11 million? Keep in mind that this problem is in millions, and you can eliminate writing all the zeros. We can just put 11, 1 minus 0.026 to the power of 15. Okay, so when we put that in our calculator, 11, 1 minus 0.026 to the power of 15. 7.41, right? So does that mean there are 7 people now?
The 7.4 million.
Million. It's all in millions. So we say 7.41 million people.
I have a question about that.
Okay, hang on. Right now, I'm going to give you 2 minutes. You're going to do the other one with 30 years. So go. Okay, so we get 4.99 million for that one. Okay? Right, any other questions? So on the test and quiz, I will specify the decimal place. Okay, so I'm actually going to stop here. I'm not going to the other page. Okay? So I'm going to stop here and